All right, so in problem 2.10, we have some airplanes flying. I think the trickiest part of this problem is reading it really carefully and drawing the right picture. The airplanes are at the same altitude, okay, and they're 80 miles apart. So it doesn't matter how high they are, they're at the same altitude. So in my picture here, which I probably should have made bigger, hopefully you can read it, I put one going north. The northbound one's going 200 miles per hour. The southbound one's going 150 miles per hour. They're at the same altitude, but they're 80 miles apart. So they're not going to hit each other, right? They're going 80 miles apart. So that's the picture here. I always make it so like the faster one is a longer arrow. The slower one's got a shorter arrow. That's how you represent it. They look kind of the same size, but that one's a little bit longer. Actually, a little bit longer still. All right, so the first question is, how far apart are the planes in 20 minutes? Well, obviously, right now, they're 80 miles apart. Okay, so in 20 minutes, where are they now, right? So that's, okay, they made it kind of easy. That's 1/3 of an hour, right? So 20 minutes is 20/60ths of an hour. So 1/3 hour, so we'll change it to hours here. So in 1/3 hour, okay, this plane, the distance it's gone, is velocity times time, which is 200 times 1/3. Okay, that's really not nice. I think they've made it 240 or something. Okay, 200 divided by 3, that would be 66 point, yeah, that'd be like 2 divided by 3, 66 point. Okay, how many decimal places do you keep? I don't know, 66.666 forever. Miles, that's the distance it went. Miles per hour times hours gives you miles. The other one, it went 150 times 1/3. Okay, they were nice to us there. That's 50 miles. Now, one of them's north, the other one's south. So if we redraw the picture here, we have this one here. Okay, here's where they used to be. This is 80. And now this one went up 66.6, so 66.666, and this one went down 50 miles. So how far apart are they now? So what you gotta do is draw a line between those two things. And what is the distance of that black line, right? And because it's just a Pythagorean theorem thing, redrawing it, it really looks like this. We want to know this distance. The horizontal distance is 50 plus 66.66, right? So, and then this distance here, they're still 80 miles apart this way. So still 80 miles apart that way. And we have 50 plus 60, that would be 116. Yeah, 116. Oops, not 166. 116.66 forever. And now we can figure out d by the Pythagorean theorem. D squared is 80 squared plus 116 squared. You can figure that one out. Okay, so a lot of this one is just drawing the picture and figuring out what's going on here. That's part A. Or there's no part A, they just asked two questions. And then how far apart are the planes in 20 minutes? Okay, that's what we did. When are the planes 300 miles apart? Okay, that's a little bit trickier. So when are the planes 300 miles apart? Now, let's redraw this picture. So we want the distance to be 300 miles. We know this side is always 80 miles. The horizontal separation is always 80. And this side is a combination of things. It's the sum of how far this plane's gone and how far that plane's gone, right? So the distance of the one plane, distance of the first plane, the northbound plane, let's say the northbound plane is 200 times time, right? Velocity. It's always good to write formulas first. So I'll do that here. It's velocity times time, which is 200 times time, where time is in hours. The distance of the southbound plane is its velocity times time, which is 150 t. And this distance is those added together. That's what you kind of saw here, right? This one's 66.66, this one's 50. We just add those together. So this distance here is 200 t plus 150 t. That's how far apart they are up and down, north and south. So this stays the same. This distance, 200t plus that, equals this squared. So now we just have another Pythagorean theorem problem. So 300 squared, or let's say this squared plus that squared equals that squared. So 200t plus 150t squared plus 80 squared equals 300 squared. And now you solve for t. You got to square this out, so be really careful squaring things out. You're going to get some big numbers, 200t squared and stuff. Remember, it's always this one squared plus that one squared plus 2 times them multiplied together. So 150 times 200t squared. This times that, 2 times them multiplied together. So you'll get a lot of t squareds, and looks like it'll always be t squareds, and then you do all the math and you solve for t. Okay, and I'll let you guys do that. I think you can handle that. So again, a lot of these problems, it's really understanding the picture, drawing a really good picture, trying to figuring out what's going on here. These basic formulas: distance is velocity times time, velocity is distance divided by time. You just got to be really handy with those formulas. They come up a lot. Time is distance divided by velocity. You just have to know those really well and be ready to use them. And make sure units are correct. They didn't try to mess us up too bad here, except for the 20 minutes. Okay, I'll let you finish that.